Kwa wataka tuifanye namba 9 namba iko wapi? Tume nini? Kwa njia gani?
Hi everybody who is watching this video. I'm Sir Olenjolai TAYAI single from the beautiful, fantastic, unique and wealth country called the United Republic of Tanzania. So in case that maybe you're shining or you're wondering enough, this is our national flag. I would like to welcome you into this fantastic session of engineering mathematics. Well enough, before I would like just to spend a few minutes or couples of the minutes just to give a little introductions of the visions of the channel. And I have, this is our official YouTube channel called Online Diploma Poly Institute of Tanzania, in square bracket Olenjolai M. It's our official YouTube channel. And then I would like to welcome you into this official YouTube channels. The way that the name is indicating that online diploma, the methodology is online, every word that has a meaning. This is diploma, it means the level that I'll be teaching in this YouTube channel. This Poly Institute, this is combinations of the two words. Poly means polytechnic. Institute, this is the abbreviations of institution, of what? Of Tanzania. It doesn't mean that I'm teaching only Tanzanians. This is a global program, so everybody can benefit from this material, but I'm using the syllabus of United Republic of Tanzania because I should have a focus. I know the mathematics should be learning in India, I know the engineering mathematics should learn there, but you might find it a little difference because I made a research before I established this YouTube channel. So the main visions of these problems, of this vision is I'm solving a particular problem. And the problem is this: when I was at my undergraduate studies at the Dar es Salaam Institute of Technology, I experienced many problems that have been encountered into the ordinary diploma students. And the problem, one of the problem is based on the engineering mathematics, and the main problem that the students fail to understand differently, or the 6 modules of engineering mathematics in ordinary diploma. I began to solve it when I was there because I'm solving problems in any community that I used to be. I began to solve it, but wasn't enough because of the time. So you know that I have to teach maybe 6 modules for ordinary diploma. There are 3 classes, or there are 3 levels: NTA level 4, NTA level 5, NTA level 6. I try my level best, but I think this is the best one because it's not limited about the time, not limited about the space, not limited as to meet physically between me and the students. So the methodology that I'll be solving, how am I going to solve these problems? That are good questions right now. I'll be solving these problems because I'll be using different techniques, different teaching. The way that the name is indicating that online diploma, the methodology is online. Every word that has a meaning. This is diploma, it means the. I'll be using different kicks, right? I'll be using different approach. I'll be using different ways of teaching the engineering mathematics, which the departments where you are right now, teaching students and to help ordinary diploma students to understand the world concepts of engineering mathematics, and not only to understand, to be applicable in the small dimensions of the class of exams, no. But I want to teach them, and I want to mentor them, and to teach them to think outside of the box, to think about the real life problems that they in their community. That's why they came to the diploma level, to get the knowledge and then go and solve those problems. So I will teach students how to think differently, because I used to think differently. So in this channel, I'll be using different ways to teach you how to think differently and to think as the problem solver and not the problem maintainer or the problem creator. So that's the main goals or main visions of this channel. I'll make you love engineering mathematics, but I'll make you to think, where can I apply these concepts in my own daily life? Because mathematics, we apply mathematics in our daily life. That's the truth, and we cannot fight against that truth. For example, the developments of electronic devices, that's applications, great applications of mathematics. Writing the programming, maybe writing a certain code or certain programs by using programming language, that's the developments of mathematics. Having the mobile phone that you have, there's a lot of mathematical formulas and mathematical equations that should be executed, or they are being used in order for you to perform a particular task in an electronic device. So that's the visions of the channel. So for you to get connected, you should have an email. That's number one. If you don't have email, just spend 3 to 4 minutes to open a Gmail or to have a Yahoo email or some other emails. Then the next step, sign in YouTube. And then the third step, then make sure that you go or you search this channel, you go to YouTube search and write Online Diploma or Institute of Tanzania, Olenjolai, then M in square bracket. Then the channel will come there. Hence you'll see the red or the buttons, software buttons, which has a red backgrounds and white ratings are subscribed. Press that buttons, and then if you're using the computer, if you are using the mobile phone, it's enough, it's fine. If you're using a computer, the bell will appear there, then click that bell and choose the options of all. So from when you accomplish that process, you'll get notifications at any time when we add any video in this YouTube channel for diploma or ordinary diploma students. I will be teaching ordinary diploma students who are pursuing engineering and those who are pursuing science. So this is for scientific and the engineering diploma students. I have also some other 4 or 5 YouTube channels which I'll share you as long as when I'll be teaching you, and I'll be introducing to you. I'll be teaching you on this lecture one. Okay, so that's all. So another thing, don't be selfish. Share this material to your colleagues, share these materials to your friends, share this. There's no limitation. You know, this material can learn them in Bear, can learn them in Arusha Technical, in Arusha, can learn in the rest of Institute of Technology, can learn them in any institution, maybe in Zanzibar, in Ungoja, in Pemba, in any of scientific or engineering diploma institutions or college or university, they can learn. So whether maybe in the institution, in the mining institutions in Dodoma or maybe in UDOM, they can benefit from this material. I tell you that. So share with them. And also another thing, that when we are watching this video, please tell us in the comment sections that where are you come from. Again, another thing, because I used to make my classes very interactive for almost 11 years when I began to teach seriously and just accepted this gift of teaching. one thing which I want to tell you is, in case you want to ask questions to interact, maybe you didn't understand or you have some more questions, you want to interact or have a group discussion with other students from the world, that is a good mindset and it's a good desire. So use the comment section, which is being written here, comment section below, means left of the video that you're watching right now. Use the comment sections to ask you questions and even to answer questions of other students. And even myself, I will be visiting the comments of each video as well as I can to answer the questions you left them there. So don't be discouraged. Don't be, maybe for example, you ask a question today, it might take maybe 2 to 3 days for me to visit each video, because you know that there's a lot of things that I have to do. So I insist you ask your questions, and then tell us also in the comment sections you're watching this program from which institution, from which regions of United, from which continent first of all, from which country, and then from which region, or which, yes, from which region, from which district, from which institution, so which college or which university. So tell us in the comment section so we might know that where we have already arrived and where we haven't yet arrived. So if that's the case, thank you very much for your attention. The modules is called trigonometric and vector. Sometimes the syllabus might be reviewed, and then you find maybe the modules is called complex trigonometric and vector for some of the institutions. I saw it. Don't get confused about that, because also I teach complex number for the diploma level in this channel, but maybe in another modules, but the contents is the same. The word they say that, for example, for this institution that I'm referring to, which is the National Institute of Technology, they used to learn trigonometric and vector for in NTA level 4 for the first year diploma student. But also when they reach NTA level 6, which is the third year, the last year for the ordinary diploma, they learn another module called complex number, numerical method, and series, which also I'm teaching this channel. So don't worry about it. Maybe the modules now, the new syllabus, or the modules at your institution is not in this form, trigonometric and vector. So don't get confused. The issue is these names of the modules should not confuse you, should not limit you. The issue is check the contents. So the main topic is called the, I think the main topic is called the vector. Okay? The main topic is called or the topic that I'll be teaching you today is called the vector. So this is vector for all diploma students. You learn vector during your O-level studies, right? You learn vector during your O-level studies. You learn vector maybe during your advanced level studies. You can learn vector also during your undergraduate. So, you know, vector is very important topic for engineers and for scientists. Okay? Because you learn vector in O-level studies. You learn vector also in A-level, if you pursue the A-level, or you learn vector in diploma studies, and also you learn vector in undergraduate studies. And if also you pursue some of the programs of postgraduate, you will also learn vector, which is, we call it advanced vector now. So it's very important. I will keep on building the foundations on, because the prerequisites of this topic is the vector you learned during your ordinary diploma, during your ordinary secondary school. Don't worry in case you forgot those material, because nobody insisted you. I will remind you most of the concepts because I love you. So if that's the case, let us join in this session 1. So I will be teaching you in different ways, in different styles. So get started. This is the channel for the serious students. I would like to insist you and remind you every time, I'm very serious on this program, and I want also to have serious students. So in case that you want to join me, please take all the required material, take your exercise book, take your scientific calculator, take your pen, take your pencil for drawings, because you'll be drawing graphs and presenting vectors, and then have a good mindset for learning and be open-minded to learn something new for the rest of your life, or to recall, or to remember, or to remind yourself what you knew before but you forgot it. So spend this time wisely and let us go together at the business. Welcome. Okay, so in session 1 or period or lecture 1, let me just underline this. I would like just to introduce you 3 important things for this topic. The first important thing, this is for the entire module of your institution. I would like first of all to give you a list of reference books and materials you need to understand different modules of under diploma level, and also including vector. So reference books and materials. Of engineering what? Of engineering, of scientific, so of scientific and the engineering. So this is engineering maths. So you may use this material and books, keep them. The first required material for you to master any modules in diploma level is one thing we call the course outline. It might be one paper, course outline. We call this course outline. Okay, so the course outline of the module that you are learning. Okay, so the first contents you need is the course outline of the module. So for example, if you are learning the modules called the trigonometric and vector or complex trigonometric and vector, you have to ask the course outlines of the module of that module from your class or your physical teacher who has been assigned by your institutions to teach you. So that's very important. I checked them and I don't have the copy of them because we call it just the property of the institution. So, but I know the content. Okay, course outlines of the module are offered by your institutions or by your teacher, by your physical, just to say physical. This you'll get from your physical teacher. And in some of the institutions, they used to call this enabling outcomes. That's the first reference. The second reference book that you need, we call it Basic Mathematics. Basic Engineering Mathematics, not Basic Mathematics, excuse me. Basic Engineering. So remember that when you say Basic Engineering and Scientific, it means statistics also learns this mathematics for diploma level. Basic Engineering Mathematics. And the author of this book is by John Bell. Okay, by John Bell. So this is the author of that. So there is the 5th edition. You can have either 5th edition, but also you can have 6th edition. You can have the soft copy or the hard copy. Then the third reference book, very important book for all the 6 modules of ordinary diploma at any level. Ordinary diploma of any institutions or in any country. Very important book, because this is teaching basic engineering mathematics. Then the third reference is also called the higher engineering. You can call it the higher, not advanced, the higher engineering or higher science in other words, because the contents for science programs is the same. Okay, can be found this of higher engineering mathematics, higher engineering mathematics, and in this higher engineering mathematics we have the 6th edition. Okay, edition, it is 6th edition. Okay, you can have soft copy or you can have a hard copy. 6th edition, and the author by John Bell. By John Bell. So this is the author. And the good thing that you see something like, you used to have that, it's a mechanical structure that which we used to find the bicycles, used to find the motorcycles, that we have a kind of the pulley. So you have a kind of the pulleys, very interesting picture. So I think that you'll enjoy if you have that book. Then the first reference, you can also use another reference called the Higher Engineering Mathematics. Another book. It doesn't mean that you should have, but it's good if you have all of these reference books, because now you will be well in engineering and scientific mathematics. So engineering mathematics. So share this material for any students or any of your friends, or you can share with your young brother or your eldest brother, your elder brother who is pursuing ordinary diploma in engineering courses or in science courses. So higher engineering mathematics. Higher engineering mathematics. Higher engineering mathematics. So this higher engineering mathematics is authored by Ramana. Okay, by Ramana. So it's outside by Ramana, and then this is B.V 2007. Okay, so that's the first reference you should refer. Okay, then the fifth reference that you need to master any of the modules. For example, for this, you should have we call it, should also have we call diploma. So diploma, engineering and the science or scientific. Okay, engineering and scientists, let's say that scientists, notes prepared by the first edition, and this is the first edition, prepared by Sir Olenjolai Moko, who is teaching you right now. So you may get them by copying the notes that I'm writing on the blackboard. This is almost 80% of what I used to cover in my notes, but you can also have the hard copy of the notes, or whether the software, you can order the hard copy of the notes, you can ship it to you, then you enjoy the beauty of engineering mathematics. The sixth reference, again, you can use internet. Know that this module is for first year diploma students. So welcome to the first year engineering and scientific diploma program. Okay, internet or online. Online books. So the internet is full of the books and the notes. So you can use them. Okay? The seventh reference that you should also have test 1, call it test 1, test 2, and then tutorial, or we call it tutorial questions, QN. Should also have assignment question or assignment sheet, the past paper, right? Assignment sheet. So this we call them past paper. We start with the word past papers, or past sheets, past papers, because all of them are papers. So seventh reference should have some quality past papers, and these past papers should be test 1 of your institution for that particular module. Okay, test 2. For this case, it means should contain the vector questions, test 2, and also tutorial. When you say tutorial questions, a lecturer or the tutorial assistant should prepare a list of the questions or a number of the questions in order for you to master that concept. And also sometimes in previous years, your lecturer or some other lecturers offered what assignment sheets or assignments to the students. So for you, you should have them, and also you should have UE. This is the abbreviations of university exam for the diploma at your level of the modules. So you call it university, because I know you are first year. I should write the first exam. So in some of the institutions, you call it university exam, UE, in abbreviation. Or in some of the institutions, for example, the Islamic Institute of Technology and Technical, they don't know the terms UE. Okay? They call it the final exam. So the final exam, in abbreviations, we used to call it FE. So FE, past papers for the final exams. And also makeup testing, supplementary, can have also even supplementary past paper. I will be using all of these references on teaching you and on transferring the concepts of vector to your mind. So those are the reference books. And also another important tool is you should have scientific calculator. Very important, scientific calculator. can have by any of the authorized manufacturer. It should be original scientific calculator. I do recommend that you should have a scientific calculator known as F991, and this is called the Casio, or by Casio manufacturer. So it is F9. So this is called the Casio. So Casio is the manufacturing company. Then it is F991 MS scientific calculator. So in case that you don't have it, don't worry. I thought about how can I solve your problems of not having it. So the best, so this is the appearance of what of Casio scientific calculator. So if you close it, you see that it has a label of Casio, and also there's a back end like this one. So if you open, so this is the appearance of Casio. So it is called Casio FX991MSSV, that one's. So this is the display. It has been covered by chalks because I'm using it. So this is the display, and these are the buttons. So all of these buttons, they have particular applications in diploma engineering mathematics, or diploma scientific mathematics. The good thing again, the back cover contains constants. So these are the constants that we need them sometimes in physics. If you're learning physics, or you need maybe in chemistry, you need this constant. But this is the conversions of the unit conversions. So that's the importance. I'll be teaching you step to step. And also in this channel, I used to add another requirements on how you can use this scientific calculator successful to assist you or to aid you in your process of learning. So in case you don't have this scientific calculator, I used to sell it. Go to the descriptions of this video. You will see the explanation, or even watch the video that is explained about it, how you can order a scientific calculator books online, okay, under the Olenjolai bookstore, and Olenjolai Olenjolai bookstore. So I can ship it. It means that you'll find the price of different scientific calculator that I have. You can order, you can add the shipping cost, then I can send to any regions within 31 regions of United Republic of Tanzania, and you can have it within a short time. So no need for you to hassle. I have tried my level best to answer, because remember that the one thing that I want to warn you, there are many sellers of these scientific calculators, but the issue is this: some of the companies, they used to make a fake scientific calculator and label the way it is and have an appearance like this one, but internally it's fake and it's cheap price. So take care about that. So that is the very important reference tools. We call it scientific calculator. So that's the first thing, or the first thing that I wanted you to know. All of these books, all of this reference material, you should have all of them, so you can have at least 3 to 4 of them for you to learn engineering and scientific mathematics for diploma level, not for undergraduate level, not for postgraduate level, for diploma level. Okay, and then I would like just to share with you the second thing. I would like to share with you Olenjolai's big picture. Okay, I would like to share with you Olenjolai's big picture, and I need much space. Okay, don't know if this space will help me or will. Okay, so I would like to share with you Olenjolai's big picture. Big picture in what? This is my big picture in mathematics. How do I view mathematics? Okay, big picture of what? Of maths. So you can call it mathematics or maths. So this is my big picture, you see? So in mathematics, I can break mathematics into 2 branches, right? And these are the 2 branches. We have a branch, we call it pure mathematics, pure maths. And also we have another branch we call it applied mathematics. And the meanings for me to share with you this big picture. Applied mathematics, pure mathematics, applied mathematics. So pure mathematics you used to learn in A level, in advanced level, advanced secondary school, so you spend 2 years in the United Republic of Tanzania. And also pure mathematics you can learn at undergraduate level and even at postgraduate level, the master degree and even the PhD or the doctorate in pure mathematics which specializes specifically in the subject of mathematics, and there are different programs that you can enjoy on this. My main focus, because engineers, we don't find us much in this part unless that we have polytechnic institutions that allow us to do maybe the 2 diplomas of pure mathematics and something engineering, right? But my main focus today for this lecture, we have applied mathematics. That's what I wanted to share with you. So it's applied mathematics, what we said. So it's applied mathematics, also we can break, it means we take the concepts of mathematics and apply them somewhere. We have many applications of applying of mathematics in real life or in different fields, but I want to share with you a few of them. So here we may get one of the branch which is called we can have or we can apply mathematics in science, called the scientific maths, which is very concerned at the diploma level, and also we can apply mathematics. These how many are these 6 verses, right? And then the chorus is a vector. I love mathematics and I like mathematics, and I want also to let you, means to make you love mathematics and like mathematics more than I do. Okay, so terminologies of 40 of vector. Then the next content, so the next concept that I want to teach you, I love this student in this module or in this topic, I will teach you about okay, so terminologies. So yes, after introductions of the vector, then I'll teach you the next concept that we call when you say introduction of vector, all of this is introductions of vector, okay? Then this we call representation. I'll teach you representation in different way, in exceptional, unique way. Presentation of what? Presentation of vector. In 3 dimensions, so I'll teach you presentation of vector in 2 dimensions and 3 dimensions, and believe me, you'll enjoy the secret which has been hidden there. Then I'll take you the same concept which we call the terminologies, right? Terminologies of what? Terminologies of vector. You have to enjoy engineering diploma or basic engineering diploma, basic engineering and science diploma mathematics. Okay, the first subtopic, I will teach you about laws of basic operation. However, that we won't do all the basic operations, but we do at least 3 basic operations, addition, subtractions, basic operations of 40 of vector. So we have some laws that govern us. You know, but I'll remind you, in case that you forgot. Operations of vector. So I will teach you about operations of vector. Operations of vector. That's still in the subtopic of 40, fundamental. Operations of vector. Okay, operations of vector. The 6th subtopic, I will teach you about ratio theorem of vector. So now we'll be leaving, so up to the 5th concept, we have covered the fundamental vector. So the 6 concepts we start, I'll be teaching about the 2nd subtopic, that's called the ratio theorem, and give you some examples or some problems. We also solve some simple problems there, the fundamental vector. After ratio theorem, I will teach you dot product. That is the same subtopic. Dot product of vector, which is scalar, and the results will be the scalar quantity. This is the scalar quantity. And then number 8, I'll also teach you the next concept, applications of what? Of dot product of the vector. Then the 9th concept, you have to enjoy. I enjoy teaching this stuff. I believe you can yourself, you enjoy watching this stuff. Mathematics is not an enemy. Listen to this phrase and remember for the rest of your life. Mathematics is not an enemy of engineering student. Mathematics is the best friend of engineering student. Mathematics is not an enemy of science student or scientific student. Mathematics is the best friend of scientific student. Okay? So if that's the case, now we say that the next concept, I'll teach you now about the cross product. Cross product, remember that it's already the first subtopic. Cross product of what? Of vector, which the resultant is what? We use also this concept of cross product in matrix applications of the 3 not 2 by 2, 3 by 3 matrix, 4 by 4 matrix, 5 by 5 matrix. We use this concept of cross product. So listen careful. There's a close relationship between vector and what? And the matrices. Very important, because we used to make columns and rows, especially in Excel, by using the matrix. Okay, so cross product of what? Of vector, of vectors. Okay, then the 10th application, I will be teaching about the application of what? Applications of cross product. Cross product. Cross product. Cross product of what? Cross product of vectors. Cross products of vectors. So what are the applications? Then the 11th concept that I'll teach you vector equations of the line. Vector equations, just we used to introduce to engineering and science students. Vector equation of 40 of a line. And then the 12th concept, I will teach you about vector equation of the plane. Vector equation of the plane, or we call it the plane vector. Okay, and hence the 13th concept, I will be teaching you how you can solve problem solving regarding vector for diploma, science, and the engineering program. So you see, so let me clarify and relate. The first subtopic is fundamental vector. So I break it into five concepts. I'll teach you introduction of vector, I'll teach you presentation of the vector, I'll teach you terminology of vector, I'll teach you laws of base key operations of vectors, I'll teach you operations of what? Of vectors. That's all about fundamental vectors. Then you have ratio theorem. I'll teach about how we can derive the ratio theorems and how we can use the ratio theorem to solve vector problems. Interesting. When you say ratio theorems, you have to remember the concepts of ratio in coordinate geometry. Learn also about the ratio, how you can find the ratio of equations of the line. Then we go to the third subtopic here is dot product. So I'll teach you what the means of dot products are we find in vector and some of the applications of dot product. Then we have another subtopic we call the vector equation, right? Now cross product. So I'll teach you what the means of cross products in this concept of the vector and application, some of the applications, not all. In advanced mathematics, at least, that we start with more applications compared to a few applications, especially just like to derive the sine rule. Here we derive sine rule. Here, one of the applications in that I'll teach you in dot product is how to derive the cosine rule by using the dot product. You can learn also how to derive them by using the trigonometrical concept, but we use also derive them by using vector. Beautiful. That's why the model is called trigonometric and vector, because there's a closest to the relationship. Because for example, the formula of the dot products, you say that we take vector A dot to vector B, cosine of angle theta. So where do we learn cosine? In trigonometry. That's why that we call this model. So these are relating topics for engineers. Okay, then we go to the the fifth subtopic called the vector equation of the line. So I'll teach you here. We just build the foundations for you. It's not too much about what I used to teach in advance. If you want to go further on learning everything that all of these subtopics, make sure that you go to to my YouTube channel for advanced level. We call it Tanzania A-level Sec School or Sec School. Olenjolai, Tanzania, we call it Tanzania Online Seki School. Square bracket Olenjolai M. Like that. Okay, so then the next concept will be, the next subtopic is plane vector or vector of a plane. So I will teach you about what the means of vector of a plane. Then I will take some of the problems in past papers, because I will use those past papers from test 1, test 2, UE exams, final exams, and solve them from different reference books. So that's the meanings of this concept of problem solving. But remember that the issue of problem solving, I can practice it in any of these subtopics. But maybe at the end I can end maybe one lecture on problem solving regarding some vector. That's what I mean. But doesn't mean that I'll be teaching the concepts and then we'll wait into these videos and we can have problems. So no, in each of the concepts, we'll be having some problems to solve, like, according to the what we have covered. Okay, so that's all about the contents and the subtopic. So allow me to take you now just to cover these concepts of introduction to vector, and that will be the end of lecture 1, and you have to wait. The next lecture is lecture 2, where in 5 semesters I did 8 semesters. Means my programs, I studied 8 semesters, but I did only 5 modules in 5 semesters. I was unhappy because I missed the modules of mathematics for my 3 semesters, because I love and I like mathematics so much. Okay, so let us go to the fundamentals. So the subtopic that I want to teach you or want to introduce to you is called the fundamental. Say with me, fundamental of what? Of vector. So if you're watching in group, tell him or her, now we are learning fundamental of vector, and then the concept that you want to cover is introductions of vector, which is not actually too much details, okay? So hence the concept now is, introduction of vector. This material also might be used for O-level students, A-level students. Yes, so they are useful. So in introduction to vector, I would like just to teach you 2 key points. The first one, the meanings of vector. So the first one, we have to know the meanings of vector. So the fundamental question is, what is a vector? Or define the term vector. How do you define vector in engineering and science? The term what is vector? Or what the meanings of the term or the word vector? So I found 2 definitions of this terminology, very important terminology in engineering and even in science. A vector, this is one of the definitions found online, so I use the reference material that I shared with you, is any physical quantity. We have many physical quantity, but this is condition, is any physical quantity, say with me that physical quantity, and the concepts of physical quantity we learned in measurement as the first thing, as the second topic, second or third, depends to when you have learned it during our O-level basic physics, is any physical quantity which can only be described full by its magnitude. Okay, by its magnitude and what? And the direction. Its magnitude and the direction. Its magnitude and the direction. So that the meaning of a vector. A vector is any physical quantity which can only be described full by its magnitude and the direction. Or some of the references, or we say that a vector is any physical quantity. Is any physical quantity. Is any physical quantity. Is any physical quantity which has both magnitude and the direction. Magnitude and the direction. So it's any physical quantity which has both magnitude, the rest. This is a familiar definition to many of the students. What are the examples of vector? That's the next question. Examples of the vector quantities. Examples, we have many, but the first or the fundamental one is displacement, display, called the displacement, displacement, okay, physical quantity, and then we have velocity, another physical quantity, we have force or acceleration. You know all of this stuff. Acceleration, also the other ones is called the force. Then the other physical, other vector quantity, for example, pressure, whether it is static or dynamic pressure, but it's sort of is a vector. The other example is momentum, and also the other one is torque. All of these are etc., 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 because we have many physical quantities. We have another vector quantity called the electric field strength. We have also another vector quantity called the gravitational field strength. We have against another vector quantity called the magnetic field strength, which we call magnetic flux density or electric field density. So we have many vector quantities, and are very important for scientific mathematics and also for engineering mathematics. Okay, so those are the examples of vector. Again, we say that the concepts of vector, I want to make a sentence here. The concept of vector is very important, or is applicable, or is highly applied in many engineering, right? In many engineering and science disciplines or programs, or condense programs, or condense courses, right? Courses, okay, courses, etc., etc. So it's highly applicable, it's highly applied in many engineering, science, and or disciplines, or program, or course. Again, another thing we say that, for example, how do we encounter the vector physical quantity? Suppose that maybe you're not even you're not engineer, you're not a science. How can you find the problems relating on vector? It means that how can you think in terms of vector to solve a real life problems? So any problem that is asking you to need the magnitude of a certain physical quantity, and also asking to know the direction from the starting to where it's directed, then there you need the concept of the vector solving that problem, right? That's a beautiful challenge. So let us take a simple problem, okay? Okay, problem statement, right? Problem statement. So for problem statement, what we say, we can use this problem statement in any kinds of the environment. Let us take just the fundamental kind of environment, whether you studied or you don't know how to start. We say that this is the case. Suppose that maybe Mr. and Mrs. or Mrs. Juma or Mrs. Let's say Mr. or Mrs. Masawe, okay, Mrs. Masawe wants to walk, right, from the village, let's say called the Uru, or called the Boma, right, towards another village called the Machame, for instance, Machame. So the fundamental question, fundamental questions of what? Of Mr. or Mrs. Masawe is where is the direction? So where is the direction of what? Of Machame in reference to what? In reference to Boma. So then that's the question. This fundamental questions is asking about directions of Machame. Whether Machame it is north of Boma, or Machame it is south of Boma, or Machame it is east of Boma, or Machame it is north of Boma. So that's, in that simple problem, Mr. Masawe didn't go to even nursery school. He don't know how to start, don't know how to read. But now he has the problems to know the directions of Machame, because if you go from Boma in this way, you have a certain destination. If against this is your Boma, or you are in Boma, you want to go in this way, you have another destination. Against if you're in Boma and then you move in these directions, then you have another direction. Suppose that's the north. And if you are in Boma and then you move in this direction, you can have another destination. It may be Machame or not Machame. So you should know the particular directions of Machame as a reference of the place where you are. So these questions is asking about your direction. So the demand of Mr. or Mr. Masawe is the direction of what? Of Machame from what? From Boma. So it's asking. So because you're asking about direction, and then Mr. Mrs. or Mrs. Masawe will take a walk to Machame from Boma, and then the speed now, the velocity, it means that the speed may be walking, let's say, 5 meters in a second, or let's say, that's not possible. Let's say, maybe, yes, 5 meters in a second, or let's say 2 meters in a second. So it means its velocity will be 2 meters, or its speed will be walking in 2 meters in a second, or maybe 1 meter in a second. So the speed will be 1 meter per second. So then the issue now is directions. So he has to know directions of what? Of Machame from Boma. So that's how vector comes. So we know that we have many of stationary and the dynamic systems in engineering, in science, that ask us about directions. For example, again, think now. You are a pilot or you are an engineer that you have to design a trajectory of the flight, maybe from Jania Julius Nyerere International Airport to Kilimanjaro International Airport. So then directions matter. So you find that in many cases in daily life we apply vector without taking a note that we are applying vector. Interesting? Okay, thank you. So then, now you know the problem statement that we are trying to teach you to solve in engineering problems. So that just like an example, okay? So the next part that I want to spend a few minutes to teach you is how do we notate a vector in engineering and scientific mathematics. So this we call it still in the subtopic of fundamental notation of vector. Very important part, notation of vector. Okay, so we saw that vector is very important in engineering mathematics and also in scientific mathematics. So how do we do notation? That's the question that we have. So there are four ways of notating a vector in mathematics in general. It means in mathematics, whether engineering mathematics or scientific mathematics in mathematics. The first way of doing this notation means that by using, can notate a vector by using two capital letters, okay, and these two capital letters with an arrow above, an arrow above them. And the meanings of using two capital letters in this case, except for some special notations, especially that in science, in magnetic or in gravitational or in electricity or in magnetism, we have special notations where we use only one letter with an arrow at the top of it, or in mechanics, in classical mechanics, according to Newton's. So there's a meaning for this. But also even whenever that we use the one capital letter, we still restore the meaning. Okay? So we say that by using two capital letters with an arrow above them. So example of this notation, we notate vector basically in this way. For example, OA. These are the two capital letters and then we have an arrow here. So this is the vector notation. And also you can have OB. This again is what? Another vector notation or another example. Or you can have OC. This again is another notation. Or you can have AB. This another vector notation. Or you can have PQ. Another vector notation. You can have QR. Another vector notation. What does it mean? Okay, let me explain to you. The first capital letter indicates the initial of the vector, because a vector should have an initial point and final point. I'll just show you soon, right now. By drawing. So it means that the first letter represents the initial, the starting point of the vector, and this is the final point where the vector is ending. This is the initial, ending of the vector. Beginnings of the vector, the ending of the vector. Beginnings of the vector, ending of the vector. So for this case, when you have OA, maybe OA and OB, this is, we call it, later on we call this the positional vector, because it's starting from origin. So all represent origin in mathematics, or in engineering mathematics, or in scientific mathematics. AB, this is not now or positional vector, this is a displacement vector, right? So because it's from one point to another point. So very important, because there's a close relationship between vector and coordinate geometry. So the simplest presentations in plane, we can present a vector like this. This is initial point. Suppose that this is O and this is A. So this one in engineering and also in science or in mathematics in general, you have this notation vector OA, initial depth. So this we call it initial point. So this is initial point of the vector. And this is OT, final point of the vector. Final point of 40 of the vector. So that's the first notation. The second notation, or the second way that we notate, which I call it the special notation, is we can notate by using a capital letter with an arrow above. Okay? By using a capital. When I say capital, it means one capital letter. Capital letter, right? With what? With an arrow above. And I reveal to you the secret, what the difference between the first way of notation and second way of notation. So in this one, examples, we use these notations in science, especially in physics or in chemistry. For example, these are the notations of what? Gravitational field strengths, or we call it electrostatic field strengths or electric field strengths. And then maybe we can use in classical mechanics, we can also use to make notations of the force because the vector quantity. Also in magnetism, we can use this to represent magnetic flux density, or we call it magnetic field strengths. So those are the sum of examples, etc. So when we be using these examples, we make assumption that this electric field is starting from a certain point to another point, so always is starting from origin. And the meaning point, the meanings of this of this notation. But this is the notation that this is the physical quantity, but it's the vector quantity. Gravitational field strengths, or we call it electric field strengths. This is force, right? Mechanical force, and this is what magnetic flux density, or we call it magnetic field strengths. will cover them in physics if you will find this notation in physics, okay? Because I'm also teaching what scientific mathematics. The third way, we say that we are using a boldly small letters. We can take a vector by using a boldly small letters. If you have any question, don't hesitate yourself to ask in the comment sections. Boldly, say boldly small letters. So when you say boldly small letters, we have, for example, if you want to present a vector, we can use the boldly A or the boldly A. Okay, and this should be a lowercase. So we can use the bold. In most books, we use notate vector by using this letter. Or you can use maybe a boldly B. Present that this is vector B. So the name of the vector is vector B. Or you can use maybe the boldly C, because we have mathematicians have chosen special letters to present vectors. Not every letters can use to present a vector. So those are adapted representation. So you can find boldly A is equal to a certain value. Okay. The first way of presentation is by using, so the first way of presentation, we rotate vector by using a small letter. So by using a small letter and dotting and wave line is candy by using underline by using not underline by using wave or underline a wave small letter underline by using wave underline by using wave underline by using wave underline the small letters. And I will give you an example because we use these notations throughout of this topic. Okay? Underline small letters. Line small letters. So this is the notation. So example of this case, example of this notation, we have lowercase a. So we can present lowercase b, lowercase c, lowercase d, etc. So lowercase against can have q, maybe have vector p, etc., etc. So whenever you see those notations, we mean that that is what vector notation. Or you can have I, which is the direction of vector, but this is not the rotation of the vector, it's the direction of vector. Okay, so if that's the case now, I would like to say that at the end of lecture 1 or session 1 or period 1 of the introductions of fundamental concepts of the vectors, thank you very much. First of all, I thank God for being with me in preparations of these contents and even preparations of this lecture. And also he has been with me when I've been teaching you, because it doesn't mean that I'm very intelligent, but that is what we call God's grace. Because God is the one who gave me this gifting. So I used to go to him and consult him in his counsel that, Father, I want to teach your students, I want to feed them what, give me what to feed them. So I thank God for that. I thank God also for giving us the opportunity to watch this program from the beginning to the end. And may God bless you abundantly. And I'm praying, this is my prayer, I pray to God that for you to understand beyond of what I will be teaching you. So I'm praying for you and pray for me. I need your prayer in order for God to sustain and giving me commitments on this program and take you step to step and using different way of approach and different teaching aids to simplify complex concepts to become simple and useful to solve real world problems. In case that you didn't subscribe, please subscribe before you go to the next lecture. And in case that you want to visit some other lectures or some other videos, don't hesitate yourself. In case that you didn't share with your friends, or you have been, you have a solid foundation of vector, you know a friend or your young brother, your young sister, somebody else in the world, wherever in the world who is doing the diploma programs in science or in engineering courses, don't hesitate yourself to share the link of this channel, the links of this video, and even tell them and commend them to go through, because this is the time to have the light and solve problems by using the fundamental concepts of mathematics. Thank you very much. See you in the next lecture of Vector. This is Olenjolai from the beautiful, fantastic country called the United Republic of Tanzania, and this is the national flag. See you in the next lecture. I love you. May God bless you.